Docker, guys. What is Docker? So what is Docker? So Docker plus Kubernetes plus Jenkins, guys. So from now onwards, our real time starts, guys. So you guys, every day you guys can join and every day you guys can practice it, guys. So Docker plus Kubernetes plus Jenkins. So prerequisite, what you need, basics of Linux. You guys are know basics of Linux and course content, something like a Docker, Kubernetes, and Jenkins, guys. So Jenkins and so in this part we will cover one real-time project and then we will show the another real-time project, guys. Okay.
Okay.
Yes. Yeah. So before that, paint. Yeah, guys. Uh, so this is a physical. So this is a virtualization and this is the containerization, guys. So physical server, virtualization, so containerization, guys. So virtualization, containerization, guys. So what is this, guys? Containerization. Container. So containerization, guys. So what is physical? So initially, so our application will be deployed on the physical servers, right, guys? Our application will be deployed on the physical servers. So then later, a big innovation thoughts comes into the picture and virtualization comes, right, guys? So that time, so we will be divided into parts of we will divided the number of guest OS in the virtualization, then we will deploy our application in this VM, right, guys? So this is our server and we deployed our application, right, guys? So this is the virtualization. And again a big thought comes into the picture and there is a solution called as a containerization. So containerization, for example, this is a physical VM or a virtual VM, the physical or a virtual vision, guys. So if you install any one of the physical virtual visions, so we can run the containers, guys. So we can run the containers on our application whenever you want. You can stop the container and you can stop and start the containers. You can stop and start the containers. So guys, for example, this is our development environment. So this is our uh, QA environment. This is our staging environment. So this is our pre-prod environment. So for example, if developers are developing the code and testing the code in the development environment, so we will stop the containers, these three environments. So based on the CPU and memory, so we will create our environment so within one server. So before we can create this is it's initially it is a physical server, so then virtualization, then containerization. Your application your application and OS image, so within 1 GB they are creating as a container. They created as a container, so with our OS and the application, with our application. Guys, understood now? So initially, so what we are using the physical servers, right? Dell PowerEdge R710, something like. Then they created a virtualization. They installed the virtualization, and so we installed the OSS. So and we deployed our application. So now containerization. So containerization called as a within 1 GB your application, your code plus image. So it will create as a one within 1 GB and run it in the container. So So before that, if you want to run a container, definitely we need a Docker container, guys. We need a Docker container and OS. So it automatically runs the containers, guys. Guys understood? Guys understood? I speak out, guys. I already told you many more times, right?
Bro, are you able to hear?
Yes, yes.
బ్రో కొంచెం ఓవర్ వ్యూ ఇంకోసారి కూడా కొంచెం
Istan,
తెలుగులో కూడా.
Istan. So HTML application development stack. So in the application development stack, HTML content and templates, CSS style sheets, client-side JavaScript including frameworks such as Angular or React, build tools such as Maven or Gradle, web servers such as Apache. So server-side runtimes and frameworks including Node.js, PHP, Python, Ruby, .NET, Java, etc. So databases such as MySQL, MariaDB, SQL Server, MongoDB, other services for caching, messaging queues, Redis and Kafka, Git, GitHub for source control. So this is the application development stack, right, guys? So setting up the deployment development stack. Setting up the development stack, for example. So this is the laptop. So you can create the front end, back end, DB and environment. So these are the multiple servers. You deployed the multiple servers, right? So issues with the development stack setup. Issues with the development stack setup. So you use a Mac OS. They use the Windows OS. You developed the app using the Java. They have a Java 11 installed. So you used a MongoDB 3.6. They are using the 4.2. This code does not work. So, well, it worked on my system. There is a difference. There is a gap between these two people, right? So you used a Mac, you used a Windows OS. So they developed an app using the Java 1.8 version. They are using 11 version installed. They used a MongoDB. They are using the 3.6 and 4.2. So there is a version difference, right? So in the virtualization, so in the virtualization tech 6, this is the VMs, hypervisor, and host OS. So advantages: multiple OS in the same mission, easy maintenance and recovery, lower total cost of the ownership. Disadvantages: multiple VMs lead to unstable performance. Hypervisors are not as efficient as a host OS. Long long boot up processes. So long boot up process. This is for the virtualization advantages and disadvantages. So containerization. So containerization advantages: host OS, container engine, and you can launch the containers. You can launch the containers. So advantages over the virtualization: containers on the same OS kernel are lighter and smaller. So containers on the same OS kernel are lighter and smaller. So better resource utilization compared to the VMs. What is that? Better resource utilization compared to VMs. Short boot up process. What is that, guys? A short boot up process. So VM versus Docker. So VM versus Docker. This is the VM. This is the Vickers. So what is that? The size is a big VM, but the size is a rabbit, something like it's a small. So the VM startup is very slow. So compared to the Docker. So in the integration, so it is very difficult to integration also. So containerization. So everything front end, back end, DB, environment libraries and dependencies, everything will be working in the as a container. So everything will be working as a container. So working on every system. So working on every system, something like works on my system, mine to, everyone. So either Windows or Linux or a Mac OS, guys. So what is a Docker? Docker is a platform for packaging, deploying, running an applications. So what is a Docker, guys? Docker is a platform for packaging, deploying and running application. Docker enables you to separate your application from your infrastructure so you can deliver software quickly. So Docker enables you to separate your application from your infrastructure so you can deliver software quickly. Docker package software into standardized units called as a container. Docker packages software into standardized unit called as a container that have everything that software needs to run, including libraries, system tools, code, and the runtime. By taking advantage of the Docker methodologies for shipping, testing, and deploying code quickly, you can significantly reduce the delay between the writing code and running it into production. So running it into the production. So Docker architecture. So how you can Docker architecture? The Docker file is there, guys. So if you use the Docker file to build the Docker images, so if you use the Docker images, if you build the Docker images to run easy as a container, Docker container. So this is the architecture, guys. Docker file, Docker images, Docker containers. Guys, everyone can speak out. So what is the architecture, guys?
Docker file, Docker image, Docker container.
Yes, very good. So Docker file. So we can create the file. So we can create the file. By using the file, we can build the image. So once build the image, we can run as a container. We can run as a container. It's a simple, it's a lightweighter. So Docker terminology, guys. Docker file, Docker image, Docker hub, Docker registry, Docker client, Docker container. So what is it? Docker file, Docker image, Docker hub, Docker registry, Docker client, and Docker container. So the complete architecture, guys. So in the client side, so what you can what you can use the commands: Docker build command, Docker pull command, Docker run command. So Docker build, Docker pull, Docker run command. So in the Docker host, in the Docker daemon is running. So these are the containers. These are the containers. These are the images. So in the registry, so what is a registry? GitHub is the GitHub is the registry or a repository. They same like as a Docker. They created their own a registry. A registry is nothing but a Docker repository. Docker.hub.com. So you can also sign up this Docker account, guys. So what you guys can do, you guys can sign up this Docker account. So before a tomorrow class. So I already created a Docker Hub account, guys. Yeah. So that images, whatever the images, right? So this is called as a artifactory, guys. What it is? Artifactory. So artifactory. So artifactory is nothing but is uh, is nothing but the images Docker images will be storing in the repository. Guys, understood? Artifactory is nothing but the Docker images will be storing in this repository. So we can Docker pull. So Docker pull is nothing but a download the download the Docker images. Download the Docker images from artifactory to from registry or artifactory. Artifactory to your Docker mission. Your Docker mission. So Docker push send the Docker images your from your local mission to uh, Docker Hub. So Docker Hub repository. So Docker Hub repository. The same like guys, git pull, git push, right? You understand the git pull, git push. So what you can do? So we can pull means download the Docker images from the artifactory. Git push means send the Docker images from your local mission to Docker Hub repository. So Docker build, Docker file, Docker a file, guys. So Docker file means so we can build we can build the Docker images from Docker file. So Docker file, guys. So Docker file. So so we can create our own Docker images. We can create your own Docker images, or you can you can download it from the Docker Hub community. Docker Hub community, guys, understood? So we can create our own Docker images, or you can download it from the Docker Hub community. The same like as a so AWS AMI, right, guys? Amazon mission image. So Amazon mission image, the same like as Amazon mission image. So you are downloading, you are using the community. So community AMIs, right? They already created it and push it to the community. So or else you can create our own AMI, and you can use that AMI also. The same like as you can create our Docker image. You can create our Docker image with the Docker file, or you can use the they already the some people are created and push it to the Docker Hub repository as a public. You can also download it. You can also use it and download it the Docker images. Guys, now you understood the terminology is Docker pull, Docker push, Docker file, and the Docker images. Docker images me so Docker images and Docker container. What is that, guys? A container, images, Docker pull, Docker push, Docker hub. So Docker hub is nothing but a repository. Docker hub is nothing but a repository where our images. This is a, guys. So this is our images. I created and I push it to the images. Or else you can use you can download from the community also. Tomcat or so this is Hari Krishna Charku, right? So explore Tomcat. Yeah. So you can download the Tomcat also. So this is the image. You can use the Docker pull Tomcat. It automatically download your your Docker hub to Docker your local server. Docker hub to your Docker mission or a server. How we can download the how we can download the images, Docker images. So Docker images. Definitely we need to authenticate between local your local Docker machine to Docker Hub. Docker Hub. So you sign up with credentials, right? Sign up credentials. You can use the sign up. You can use the sign up credentials and you can authenticate with the from your Docker mission to Docker Hub. Guys, now you understood? So this is the client mission. So in the client, you can use the Docker Hub. So Docker build, Docker pull, Docker run. So in the Docker host, there is a daemon, Docker daemon is running on here. So there is a Docker images. So if you use the Docker images and we can run as a containers. So these Docker images are available in the registry. These Docker images are available in the Docker registry. Guys, understood? Yeah. So Docker commands, Docker -v, we can check the versions, Docker info, Docker help, Docker login. Yeah. How you can log in from authentication from your local machine to Docker Hub, you can use the Docker login. Docker images, we can see the what are the Docker images available in our mission. Docker PS means so how many containers are running on your missions. Docker pull image, you can pull the image. Docker run image, so run as a container. Docker build the image. Docker tag, we can create the tag. Docker push means, so we can push from your local machine to the remote repository. Docker RMI is nothing but a, so so remove images, you can use remove images. So, so application development, collection of programs is called as a software project, right, guys? Collection of programs is called as a software project. A software project contains a several components. A software project contains a several project, front-end components, user interface logic, back-end components, business logic, and database components. These are the three three components. So in order to deploy our application in a mission, we need to set up all the software which are required to our application. So we need to set up all the software which are required to our application. So what is that? OS, Java, MySQL, Tomcat, web server, everything we need, right, guys? So in runtime project, we should apply into the multiple environments for testing purpose. So dev environment, sit, so UAT, user accept, pilot, prod, QA environment, staging, integration. So these are the environments. For example, WhatsApp application example, guys. UI front end. So the web components, business components, and persist components. Persist is nothing but a database. This is a backend. So this is nothing but a front end. So this is a database. So front end, back end, database. We need these guys. For this purpose, we use HTML, CSS, Bootstrap, Angular, jQuery. So for backend purpose, we use the softwares we use Java 1.8 to Spring Boot to Hibernate to. So database we can use the MySQL. So these softwares we need to install, right? So DevOps people deploying an application in the multiple environments. So the what DevOps people are doing, guys, DevOps people deploying an application into in the multiple environments. So this is our Git repository. So this is the developers. This is the DevOps people. So what DevOps people are doing? So development environment, set environment, UAT environment, pilot environment, and prod environment. So every environment we need to install the Linux, Java, Spring Boot, MySQL. Linux, Java, Spring Boot, MySQL on these environments, right, guys? So each environment having a different versions of Java is a problem. So right before we already said, right, so Java 11, Java 13, Java 1.6 are using. So Java 11 dev environment and set environment, Java 13 UAT and pilot, so in Java 6, 1.6 pod environment. So Linux, Java, so Java 1.8 to Java 1, 1.8, 1.8, 1.8. So dev environment will be used by developers to perform the integration testing. Set environment will be used by the testing to test out functionality of the application. So environment will be used by the client to test functionality of the application. So pilot environment means pre-production testing environment. Prod means live environment. It used to deliver the project. To deploy application to these many environments, we need to take off all the softwares required to run our application. All the environments is very difficult a task. So in the virtualization, so what is the virtualization? Installing multiple guest operating systems into your one host operating system. Hypervisor software will be used for the achieve this. So we need to install all the required softwares in host OS to run our application. So this is old technique to run the applications. System performance will become slow in this process. To overcome these problems of a virtualization, we are going for the containerization concept. So what? So we are going for the containerization concept. So what is a containerization? So containerization, it is used for the package. So it is used for the package all the softwares and applications code in one container for the execution. It is used to package all the software. So it is used to package all the softwares package package so all the softwares and application code also into one container for the execution. Container will take care of everything which is required to run our application. So we can run the containers in multiple missions easily. Docker is a containerization software. Using Docker, we will create a container for our application. Using Docker, we will create a image for our application. Docker images we can share easily to the multiple machines. Using Docker image, we can create a Docker container and we can execute it. So conclusion. So Docker is a containerization software. Docker will take care of application and application dependencies for the execution. Docker will take care of the application and application dependencies for the execution. Deployments into multiple environments will become easy if we use as a Docker container concept. If we use as a Docker container concept. Guys, understood? So you guys are understood little bit, right? So when we start the installation and so creating and building and running the container, you will understood, guys. Okay. So how to install the Docker installation? Install Docker in Amazon Linux. So m update -y install Docker y. So service Docker start. Add a user to the Docker group by executing the below command sudo user mod -ag docker ec2 user. If you want to use a user ec2 user, you can use this one. So Docker commands. See Docker info. See the Docker images execute below command Docker images. How many Docker images are there? We can check it. Pulling the hello world Docker image, you can use the Docker pull hello world. So it will pull from the Docker hub, Docker repository. To see the Docker images. So running hello world Docker image, how you can run the Docker image? You are not creating any images, just you are pulling the container. So Docker images from the registry. Just Docker run hello world. It will automatically run the Docker world. So create an account in the Docker Hub, http://hub.docker.com, guys. You guys can create your account. Sign up your account in the https://hub.docker.com. You can create your Docker Hub account in the Docker Hub registry. So what is a Docker? Docker installation in Linux, Docker architecture, Docker commands. You know, right? We already know. So that for the Docker, you can create the Docker files, and Docker files you can use the Docker build command. It create the Docker images, and you can use the Docker command, Docker run command to run as a container. Image run as a container. So if you want to push it to the Docker Hub, you can push it to the Docker push here. So Docker terminology, Docker commands, Docker terminology. So Docker info, Docker images, Docker pull, Docker run, Docker PS. So Docker terminology is Docker file, Docker image, Docker container, Docker registry, Docker engine. So Docker file contains a instructions to create. So Docker file contains a instructions to create an image. It contains Docker domain specific keywords to the build image. It specifies, it contains Docker domain specific keywords to the build image. So Docker image is a package which contains everything: app code, software, environment, libraries, everything. So Docker container is a runtime instance of the Docker image. What is that, guys? Docker container is a runtime instance of the Docker image. Docker image out application will execute in the Docker container. Docker registry is a place where we can store our Docker images. Registry or a hub is a place where we can store our Docker images. So Docker engine is a software using which we will create Docker images and Docker containers. Docker engine is a software using which we will create Docker images and Docker containers. Docker engine. So we will run the Docker engine. So Docker Hub is a public repository. Everybody can store and retrieve the images. Nexus, JFrog, DTR, AWS ECR are the private repositories. What are those, guys? So Nexus, JFrog, DTR, AWS ECR are the private repositories. Docker Hub is a public repository. Everybody can store and retrieve the images. But Nexus, JFrog, DTR, AWS are the private repositories. It is a company specific. So these all are the artifactories. What it call it as a artifactories. JFrog. JFrog Artifactory. It is a, so this is also a Artifactory where our, it's the same like as a Docker, but these are the private ones. So Nexus Artifactory. This is also a Nexus. So this is the also Artifactory. So DTR. So DTR means Docker registry. So this is the JFrog Artifactory. Guys, now you understood? So JFrog, Nexus, and DTR. So Docker registry, AWS are private repositories. So Docker commands to display all the running containers, Docker PS. To display all the containers, Docker PS-A. To stop the container, Docker stop. Remove the container, Docker RM. Remove stopped container, unused images, Docker system, porn-A. So Docker file creation and tag creation. This is the Docker file creation, guys. This is the Docker files from our Ubuntu or CentOS 7. Run echo run one, run cmd run. These are the commands, guys. So by using how you can build our Docker build hyphen my first img. So dot. So you can use this dot file. So if you want to create a tag, image tags, Docker tag my first image Hare Krishna / my first image. Okay, push Docker images to the repository. Once you build the Docker images, you can also push it to the Docker Hub. So public repository. So you can use the mission 1, mission 2, mission 3. For example, development environment, non-production, QA environment, and production environment. You can use one image and you can create a one image and you can deploy it on the anywhere. You can run it on the anywhere. So this is the a big advantage of the Docker images, Docker container. So we don't need to create the environments. You see, right? So definitely we need to create these environments with the softwares. So you just create the missions and just run the Docker engine. You can you can run any container in the environment. You can create a one container and you can run it anywhere. Guys, understood? So this is the a big advantage. A big advantage. So Docker file creation. Docker file contains the instructions to build the Docker images. So in a Docker file, we will use DSL, Docker and domain specific language keywords. So Docker engine will process Docker file instructions from the top to bottom. Top to bottom. So below are the Docker file keywords from maintainer, copy, add, or run, or CMD, entry point, environment label, user, work directory, expose, volume. So from and maintainer keywords, copy keywords, add keyword, run and CMD keywords. So difference between run and CMD, entry point keywords, work directory and environment, label and org, user and expose. So Docker file from CentOS, I need to run my mission. So run. So this is the image. So port assigning to the container. I want to assign a port to the container. I want to assign a 8080 port to the container. So how you can assign the port. So Docker volumes. So Docker volumes mounted to EC2 mission. So Docker volume commands. So how we can share the data from the one container to another container. Docker volume creations, Docker volume creation 2, Docker volume creation 3. So using host file with two containers, mounting the bound volumes, host directory mounting to Docker container. So how can I mount my host mission directory to the Docker container? So that is called as a bound mount. So as of now, what we discussed below, so we discussed these things, right? So so tomorrow we will show you how to install the Docker and how to run the Docker. Just we will pull the So we will pull the code, we will pull the container from the Docker Hub registry. So Docker Hub registry, and we can run it. So we can run it later. So we will discuss how to create a Docker file and how to build the Docker images. So by using Docker file, guys, by using Docker file. Understood?
As Guru.
Right, guys?